Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my name is Sayyid Rahman. I'm student of grade 10 continuing in school to Qatar. In this video, we are going to do the question number 1 from exercise 1.3. Okay, now first of all, let me tell you in this exercise we are basically be concentrating on the roots. Okay, like the roots in sense we have to prove that they are irrational. Okay, from we have to prove that they are irrational from rational. Okay, so for example, here we in the first question. Okay, let's take the first question itself. The first question is prove that root 5 is irrational. Okay, right? This is the question. Okay, now over here, our answer will be on the contradiction. On the contrary, let us assume that root 5 is rational. Okay, so first this is our first step. Okay, after this we will take root 5 is equals to a by b, where a and b are co-primes. Okay, so we will take root 5 equal to a and b, where a and b are co-primes. Okay, then our next step will be this root 5 b is equals to a. Okay, how did we get root 5 b? This b, when we transpose to other side, it is in division, it will become multiplication. Okay, so root 5 is equal root 5b is equals to a. Now if we square, so we will square in our next step, squaring on both sides. Okay, squaring both sides, and this will become 5b square is equals to a square. Okay, now let's take it as the equation 1. Okay, now let me erase this in the upper part so that I can continue my answer. If you want, you can go back and note down. Okay, so then 5b square is equals to a square. Then this is our first equation. Then this is the most important step which I am going to write now. So that is therefore 5 divides a square, then 5 divides a. Okay, how is this possible? Because if it is being divided by a square, 5 is being divided by a square, or 5 divides a square, then it can also divide a, right? Because a square is a specific number, so that is the only, like a square is the only square of that number, and a is only the number, right? So if I can divide that specific number, so it can divide the square also, right? So that is the concept. Okay, so this is the step, and then we have more. So this is our, then let us assume the next step. Okay, yeah. So we will assume a is equals to 5c, where c is an integer. integer. Okay, then a is equals to 5c square, so we'll take this and squaring on both sides. Okay, then here this will become a square is equals to 5c whole square. Then from equation 1 we can tell that from equation 1 we can tell that 5b square over here, 5b square is equals to 25c square. Okay, because a square is equal to 5b square, right? So instead of writing a square we can also write 5b square. Now let me erase this. Okay, so then we can write 5b square is equals to 25c square. Now here we can divide it by 5, right? Because 5 is common in both, so we can cancel this and this and this. So b square is equals to 5c square. Therefore we can tell that the same step 5 divides, because here 5 is in multiplication, if we send here then it will be in the division, right? So we can tell 5 divides b square, then 5 divides b. Okay, now this was the actual explanation. Okay, now let me write the conclusion. I will erase this and write the conclusion. Okay, now this is our conclusion. Okay, after doing all those calculations we can write this conclusion. Okay, now the conclusion is so we can tell that this is a contradiction to the fact that a and b are co-primes. Okay, this is a contradiction to our wrong assumption that root 5 is rational. So do you remember that in the starting of the question, in the starting of the answer, we had taken root 5, we had assumed root 5 as rational, right? Now we had assumed, okay, but this is the contradiction. Like contradiction means like it is the vice versa, or like you can tell the opposite. Okay, so it actually reversed. So here this is a contradiction to the fact. Now what is the fact? We know that a and b are co-primes, right? We had taken a and b as co-primes. So here co-primes does not have any common factor, like they do not have any factor itself, right? So how can be phi a factor of a and b? So that is wrong, right? So we can tell that this is a contradiction to our wrong assumption that root phi is rational. Okay, rational. So we conclude that root phi is irrational. Okay, so this is the conclusion for the answer. Now this was the answer for the question number 1 from exercise 1.3. Now we will move to the question number 2 in our next video, inshallah. So thanks for watching. Thank you and assalamu alaikum.